Hey everyone, I hope you're doing well. So today we're going to start looking at our exponent rules. Sometimes you'll hear them called properties of exponents or exponent laws, but I'll just say they're the rules of how exponents work. So the first thing I'd like for you to do is draw a table, and this can take up your whole page. That's fine. So in this table, I want you to have 3 columns. I want you to make one title row, and then the rest of them, I want you to make 1, 2, 3, 4, 5. So a total of 6 rows. Probably do just a couple. 1, 2, 3, 4, 5, 6. That worked out perfect. And you'll notice my lines aren't perfect. Do the best you can. And for your titles, let's go ahead and write rule name. So we're going to give a title or a name to our rule. We're going to talk about what the rule does, like what do you do, the rule. And I'm going to give you an example. All right, so the very first rule that we're going to look at is called the product rule. And so what you'll do is these work if you have the same bases. Oh, and just really quick, let's say we have x to the 5th power. The big number, just a reminder, is called the base, or the big letter, number, whatever. And the small number, we call that the power or the exponent. So one more time, and let's say you have a number, like 5 to the 2nd power. The big number is the base, the small number is the power or the exponent. So let's say we have the product rule. You keep the base and you add the exponents. So let's say we have 5 squared times 5 to the 3rd power. You keep the base, add the exponents. 2 plus 3 is 5. Let's try another one. Let's say we had x to the 4th times x to the 3rd. You keep the base and you add the exponents. 4 plus 3 is 7. So that's the product rule. Now let's look at the quotient rule. Quotient, you'll remember, is the answer to a division problem. So again, you keep the base and you subtract the exponents. So let's say we had 5 to the 3rd power divided by 5. You keep the base, and look at this. If there's no exponent, there's a 1 there. So 3 minus 1 is 2. Let's do the same thing with letters. Let's say we had x, let's do it sideways. X to the 10th divided by x to the 4th. You keep the base, subtract the numbers. So 10 minus 4 is 6. So x to the 10th divided by x to the 4th is x to the 6th. So that is the quotient rule. So product rule, quotient rule. Now let's look at, it's called the power rule. I know it's like, aren't they all powers? Well, this is where you raise a power to the power. So what you do is, again, you keep the base and you multiply the exponents. So let's do a couple of examples. Let's say I had 5 to the 3rd to the 2nd power. I keep the base of 5 and I do 3 times 2 is 6. Let's do letters or variables. Let's say I had x to the 4th to the 5th power. So I keep the base and I multiply the exponents. 4 times 5, that's 20. So that is the power rule. You're raising a power to a power. And just to clear up, product rule, that's when we're multiplying, okay? That's when we are product means to multiply. Sorry about that. Might not should have went back to that out of order, but just that's okay. All right, so the next rule we want to look at is called the zero exponent rule. The zero exponent rule. So anything to the 0 power equals 1. So if I had 5 to the 0 power, my answer is 1. If I have x to the 0 power, my answer, or my value, is 1. So that's the 0 power rule. And next, let's talk about the negative exponent rule. Negative exponent rule. So anytime that you have a negative exponent, that just means, I'm going to say flip the fraction or flip its position in the fraction. Let me show you what I mean. So if I had 5 to the negative 2 power, 5 as a fraction is 5 over 1. So this becomes 1 over 5, and the negative 2 becomes a positive 2. Let's do the same thing with a letter or a variable. Or actually, let me do another example first. What if I had 1 over 5 to the negative 3 power? The 5 to the negative 3 is on the bottom of the fraction, so I flip it to the top. 5 over 1 is just 5, and the negative 3 becomes positive 3. I'm going to erase this line because I need a little bit more space. Let's do the same thing with letters. Let's say I had x to the negative 4 power. Well, x is x over 1, so I'm going to flip it to be 1 over x. It's the reciprocal, is what we call that in math. And the negative 4 power becomes the positive 4 power. Let's do the same thing if the negative exponent is on the bottom of the fraction. Let's say we have 1 over x to the negative 5 power. You flip it. The x was on the bottom. Now let's move it to the top of the fraction. X over 1 is just x, and the negative 5 becomes a positive 5. So these are all of your exponent rules. You can use this graphic organizer to help you with your practice. So now let's take a look at how to tackle a problem that has more than one of these rules. A lot of your questions, you can just use one rule at a time. But let's look at one that has a couple of these put together. So let's call this example 1. So let's say I have 4 to the 5th power times 4 to the 3rd power divided by 4 to the 2nd power. Well, if you look, I see two different rules. I see the product rule. So if you'll notice, this is going to be the product rule. But then when I divide by 4 to the 2nd power, that's going to be the quotient rule, because quotient means to divide. So first I would do my product rule. I would keep the 4, the base of 4, add your exponents. 5 plus 3 is 8, divided by 4 to the 2nd power. Now I can use my quotient rule to simplify even more. Remember, with the quotient rule, and again, look at your examples to decide how to do this. You keep the base, see it, and then it says subtract the exponents. So if you have more than one rule, tackle them one at a time. Let's try a few more. Let's say I have 3 to the 4th power raised to the 5th power times 3 to the 3rd power. So I notice two different rules. I see the power rule right here. See, the power rule is a power raised to the power. That's this. And then I notice I have the product rule. So let's do the power rule first. 3 to the 4th to the 5th means keep the base, multiply the exponents. See, that tells you right there what to do. 4 times 5 is 20. And then I still have to do times 3 to the third power. Well, now that's just the product rule. And the product rule says keep the base, add the exponents. So 20 plus 3 is 23. So my final answer is 3 to the 23rd power. Let's try another one. I'm going to put 3 rules together. Let's say I have x to the 5th power raised to the 2nd power times x to the 0 power divided by x to the 4th power. I have 3 different things here. I have power rule, I have a 0 exponent, and I have the quotient rule. So let's do the power rule first. X to the 5th to the 2nd power says you keep the base, multiply the exponents. So 5 times 2 is 10 times x to the 0 power divided by x to the 4th. So now, see, I want to simplify one piece at a time. Now I've got x to the 10th times x to the 0. Well, that's x to the 10th for 2 reasons. Product rule says you keep the base, add the exponents, 10 plus 0 is 10, and then divided by x to the 4th. That's our quotient rule. So we want to keep the base, and it says to subtract the exponent. So 10 minus 4 will give us 6. So our simplified answer is x to the 6th power. So again, just take it one step at a